Welcome to our rescheduled PTV Talks session for today. Today we have a presentation from our PTV experts Levi Button and Sean Fitzgerald on curb-to-curb modeling airports in PTV Vissim with PTV Viswalk. Just a couple of items before we get started. Our next PTV Talks session is PTV Bistro, which is a Wednesday on May 17th, and PTV Visum on June 1st. These sessions will be emailed separately to register. Also, if you're interested, please join one of our next web-based training courses. We have Visum Managed Lanes training tomorrow, May 10th, Visum Dynamic Assignment Thursday, May 11th, and Visro Introduction on May 24th. You can find more information about these trainings, pricing, and registration at ptvgroup.com under Events and Trainings. Next, at the end of the session, we will have a Q&A. You can enter your questions in the question box at any time throughout the presentation. And like last PTV Talks, we have a few poll questions today that will be asked throughout the webinar. They will only take a moment of your time, and we appreciate your participation. And now for our first poll question. Have you worked with Viswalk/Pedestrians in your simulation model? And we're going to give you a couple seconds to answer that. And we're going to close this question now and start the presentation. Thank you.
All right, welcome in everybody. My name's Levi Button. I am the transportation engineer at PTV Group. I do a lot of training and technical support and professional services in the micro simulation realm. So I use Vissim, some simulation-based assignment in Visum, and some Bistro stuff as well. I'm joined with my moderator today is Sean Fitzgerald. He's our senior account executive. He also has a lot of experience using Viswalk and Vissim from his days in the consulting world, and he'll be the one answering the questions. So again, if you have any questions, please type them in the chat, or and any good questions or any questions that we haven't gotten to, Sean will re-ask them at the end during the Q&A session. All right, so today we're going to be getting into talking about presenting some material on how to utilize formula-based routes, attribute modifications, and pedestrian and vehicle attribute modification objects or attribute decisions to control for different operations at an airport. We're going to be looking from the time that a person gets dropped off at the airport to the time they get picked up. So to give you a little preview of what that's going to look like, let me jump into just a quick animation. It'll take about a minute or so to run to kind of show you what we're going to do throughout the course of the day. So it starts off here. We're going to show you how you can generate pedestrian demand from the vehicular demand. And then using user-defined attributes and formula-based routes, you can assign pedestrians to different airlines and go to different kiosks. Similar thing for pre-check versus general screening. And then also, how can you manage to have different boarding times onto different vehicles? In this case, an airplane or a bus or something like that. So you might have different boarding groups. And how do you release them for those different operations? Again, we're going to be utilizing a lot of different user-defined attributes, a lot of formula-based routes, and attribute modifications. Then once the airplane or the transit vehicle proceeds to the next stop, it's going to alight all those passengers, and then again using formula-based routes to redirect them either to other gates or to exit the facility. In this case, there's a little bit where we show how to use automated people movers, because a lot of airports have those moving between the terminals. And then once people alight from those automated people movers at the baggage claim, how can you have people stand and wait for bags and then eventually collect their bags and walk to the arrivals curbs? In this case, we have two different arrivals curbs that we're going to be looking at. We have the private transportation as well as something like a taxi stand for taxis or TNC pickup. So those are the types of operations that we're going to be going through today. And we're going to get started with the departures curbside. So if you've used Vissim in the past, you might know that you can use public transit to alight passengers from different vehicles. You can also use scripts to allocate pedestrian inputs based on the occupancy of the vehicles. In this case, we're going to kind of do that, but without scripts. We're going to use the inbuilt features to do everything in this model without any sort of knowledge about Python or scripting or anything like that. So here, for the departures curbside, we have the traditional vehicle demand. So whether you're using dynamic assignment or you're using static demand, a lot of you might have already worked on airport curbsides from the landside operations. So you might have pickup, you might have parking lots and things like that at a curbside. So that's all going to be the same, right? You have your static routes, your partial parking routes. But then what we're going to do is we're going to add a pedestrian input adjacent to those parking lots. And then we're going to use an attribute modification to read the demand coming in from that parking lot and produce pedestrian input volume data. So that's going to look like is we have an object or a feature in Vissim called an attribute modification. And what the attribute modification is going to do is, here's the actual language that we're going to do. So in this case, it's looking up the parking lot itself, and it's saying, okay, based on parking lot number 1, let's get the occupancy of the vehicles from the parking lot. So it's adding up all the vehicles that are parked there, looking at their occupancy rates, and then just applying a flow rate adjustment so that we can, because the pedestrian inputs are always in pedestrians per hour, and we need to do this second by second. So we need to recalculate flow rate and how many seconds per pedestrian does it take, basically how long does it take a person to get out of a car. So that in this case, we're saying is about 20 seconds to get out of the car, grab their bags, things like that per pedestrian. And then multiplying that by the number of pets or passengers within a car. Before I go there, let's jump into the model itself. So in the model, this is what it looks like. So in 2D mode, we have our vehicle input over here, which just has a static flow right now. It might change over time. Again, this is kind of standard Vissim fare, right? However, you're going to have pedestrian or vehicles assigned to drive into the airport. It's kind of up to you. We have our standard static route that is going through the departures curbside. And then we have a parking route that is assigning vehicles to this parking lot, right? And this could be single park, it could be double park, things like that. Adjacent to that, we have an area with a pedestrian input, and this pedestrian input is just a standard pedestrian input. The only thing we need to do to get this working is we need to look at this parking lot. So if we look at the parking lot, one of the attributes that we can pull up is we can look at the vehicles in the parking lot and pull out their occupancies. So if we have random occupancies assigned, we can pull that out. And then in the actions menu under attribute modifications, we just create just a second, it's on my other screen, there we go. We create a easy formula that just says, okay, based on that parking lot number 1, pull out that occupancy, that sum of occupancies, and then apply your flow rates. And this is going to run, in this case, I have it set up to run every 5 seconds. So every 5 seconds of simulation, it recalculates. That's just to increase simulation run times a little bit. And basically, it'll recalculate this volume over time based on the vehicles that are dwelling in this parking lot. So this can scale pretty easily. So we can see how pedestrians are being generated as cars pull up. They're generating at roughly about 1 pedestrian every 20 seconds for the car's dwell time. All right. The next thing after people get out of the car is we are going to move on to the ticketing concourse. And again, if you want details, a little bit more details about this, please feel free to send it in the chat. We might follow up with you later or send questions to myself or support.us@ptvgroup.com for more details on how to manage some of these formulas and functions. All right, so moving on to the ticketing concourse. Once the pedestrians have got out of the car, now they need to walk to the airport, right? Think of yourself, you've got out of the car, you've gotten dropped off by a taxi or a loved one, and now you are moving into the airport. Some of you might go to a ticketing counter, some of you might have to check a bag or go directly to security. So that's the next kind of operation that we need to set up. Now, traditionally, what you would do is you would set that up with just a static route, right? You'd say X percentage, just skip it and go straight to security. Certain percentages go to different queues and things like that. We're going to change it up a little bit, and we're going to go to a model where the pedestrians are actually assigned different airlines based on a random distribution. So in this case, we have a static vehicle route that goes through ticketing, and then we use a formula-based route to read that user-defined attribute called airline ID or something like that. And then based on that airline ID that the pedestrians are randomly assigned, it will automatically redistribute them to the correct desks that they need to go to. And we're going to assign that attribute ID with a pedestrian attribute decision. So the first thing we'll need to do is create a user-defined attribute called airline or airline ID. And this is going to be an integer value. And this value could be any value, but typically it's going to be something like 0 equals no airline, 1 is, and then you pick your major 4 or whatever, and you go 1, 2, 3, 4, or depending on the airport and the complexity, you can add in more. You will also then create a distribution. And so in this case, we're going to go with 2 airlines. And so we just need to specify what percentage of people go to each airline. In this case, we have a 60-40 kind of split. So 40% of the people go to airline number 1, and then the remaining 60% go to airline number 2. By setting it up like this, you don't have to get into all the static routes and redefine passenger flows all the time. You can create different distribution rates based on arrival and departures and schedules of the day. So that way you don't have to constantly change static routes. Then what we're going to do is we're going to take these 2 elements, the user-defined attribute, and we're going to put it into an attribute decision. And this airline attribute is going to be updated based on the free distribution. So in this case, we have our pedestrians. They're going to cross an area with this attribute decision. It's going to look at their airline attribute, and it's going to randomly assign them an airline based on this distribution. Okay. So then once we have that distribution assigned to the pedestrians, so the pedestrians are going to be randomly assigned airline 1 or airline 2. In this example, I have Delta and United for red and blue. After that, we just use a formula-based partial route. So when they step into the ticketing concourse, they know what airline they're supposed to go to. And if that airline matches the airline ID specified in the route, they just follow that path. So in this case, the upper route is Delta Airlines, and we just have a basic formula that says if the pedestrian's airline is equal to ID number 1, which we've specified as Delta, then there's a 100% chance that they'll go to that line. Otherwise, there's a 0% chance that they'll go to that line. Why would you go to a Delta line if you have Delta Airlines, right? Same thing with United. If pedestrian airline is United, always go to that line. Otherwise, don't go to that line. And it's pretty straightforward that way. So let's take a look at that model again. Oh, sorry, there we go. Here's the actual Vissim model. So in this case, in the pedestrians and network, if we go to our pedestrians and network area, you go right click, show list. And one of the attributes that we have created is this airline attribute. And so we can assign an airline to the different pedestrians. So in this case, they're assigned airline number 1. This blue person is assigned airline number 2. If I go into 2D modes, we can see all the different elements. As they step onto the departures curb, we've placed an object called a pedestrian attribute decision. And so when you place that, it's going to open up an editor that looks like this. and you just specify what attribute you want to update and what value you want to give that attribute. In this case, we're using a distribution. So when they get out of the car, they're automatically assigned an airline. And then when they get to the ticketing concourse, they pick up this formula-based partial route that then assigns them to go to one desk or the other. And this is what that formula looks like. Basically just an if function, and then we are able to pull up the airline from the passenger. And then if that airline value is equal to 1, then there's a 100% chance that they'll go to that queue. And so that's how we would distribute pedestrians to their various queues. Now this way makes it a little bit easier than using static routes, because then you don't have to get back into the static routes. If you want to change the distribution of where pedestrians or how many pedestrians are going on one airline or the other, you just go into base data, distributions, down to free, and we have an airline assignment distribution that you can update. You can add additional airlines, remove airlines, things like that. So that will allow you to quickly change the data without having to go in and redefine all of the different features. Okay. This leads us into our second poll question. So, are you or do you have any projects that require more robust simulation, treatments, and analysis? This is just kind of getting us into getting our minds working about, okay, now you've seen a little bit about Viswalk, what can we do with Viswalk now? Okay, thank you for responding to that poll. Now, whether or not you are doing airport analysis or robust pedestrian models like airports or stadiums or something like that, these features that we're talking about, the user-defined attributes, the formula-based routes, the attribute modifications, these also apply to your private transportation. So you can still use all these features on cars and things like that. So even if you're not necessarily just doing airport modeling, try to imagine how you might utilize some of these formulas or things like that to add more details or something to your traditional Vissim vehicle models as well. All right. So after we've gotten dropped off, we've gone in, we've checked in at the airline desks. Now we move on to our security checkpoint. And this is going to look very similar to the way we did the airline check-in desk. Basically, we have our static route, which is leading us through security. So as a pedestrian, we know, okay, we need to get to Concourse A or B, right? So we have to go that's our final destination right now for this next phase of our journey. On the way to our final destination to Concourse B, we have to decide which security line we want to get into. So we're going to use a formula-based partial route to do that. And the reason we're doing a formula-based partial route rather than just a weighted route with a certain relative flow is because we're going to be using, just like we did before, a pedestrian attribute decision to assign pedestrians a security status. So as they walk into the security terminal, or maybe after they've checked in or something like that, you can do this at any time, you assign them a different security status, because you might have something like general boarding, priority passes sometimes get a shorter line, you get TSA pre-check or maybe global entry or something like that, right? So again, using user-defined attributes to assign pedestrians or agents within the simulation specific data. So in this case, just like before, we have a user-defined attribute called security status. 0 is general boarding, TSA pre-check, and crew. And then we have a distribution that is assigning people their security status based on data that you may have collected from the field, right? So in this case, 85% of people are going to general boarding, 15% of people have pre-check, right? So in this case, our pedestrian attribute decision is taking that security status and then assigning it based on this free distribution. And then again, just like we did with the check-in desks, right? We take that security status from the pedestrian. So as they walk into this area, they're going to pick up a partial route that says, all right, if your status says 1, i.e. use TSA pre-check, then, I think I have the names on this backwards because 1 is supposed to be pre-check. Yeah, so if it's 1, they'll go to pre-check and they'll have to go through this queue. And if it's 2, they'll have to go through general screening. And so they will be distributed again, making it a little bit easier so you don't have to get in and adjust those percentages on the fly. You can just create a free distribution for it. Okay. So that's getting through our TSA screening, right? So if I pan over a little bit more, we have our 2 TSA pre-screening lines. Here's the attribute decision. So again, setting that security status, and then once they walk into this terminal, they pick up their route that says, okay, either go into one line or the other. And once they've been assigned that security status, they will then join that queue. And then these queues are pretty straightforward. They're just the service point selection. So they're looking ahead and saying, okay, if there's less than 1 person there, then you can step forward, otherwise form a queue beyond. The next thing we're going to look at is once they get through security, we can send them to their various gates, again, assigning them a gate value. They might have, for example, if I click on a specific pedestrian, like this blue person right here, we could create a user-defined attribute called something like departure gate. And so just like before, we can assign them a departure gate number, and then using formula-based routes, assign them to various gates. So in this case, we have some gate numbers that go to Concourse B, some gate numbers that go to gates A2 to A5. And then if they have the gate value of 1, departure gate 1, they'll go to gate A1 for boarding. And so that's just using a formula-based route on the concourse itself. It says, okay, if your departure gate is 1, go here, otherwise go somewhere else, right? Pretty straightforward in that sense. So once you've moved on to your departing gate or your boarding gate, we're going to use a static route to navigate people to the platform edge. Now, in this case, we're using a public transit vehicle to act as the airplane, but you can imagine if this is like a touring bus or a shuttle or something, similar thing, right? So we have a looping public transit vehicle that will arrive and dwell for a specific amount of time. So we need to use a static route to navigate our pedestrians to that public transit waiting area. And then on the way, we're going to have a pedestrian attribute decision that then assigns them a boarding status, right? You might be general boarding, you might be pre-boarding, you might be priority boarding, something like that. Then we have the actual gate area, right? The space where people dwell with the chairs and the chargers and things like that. So when they navigate on this space, they're just given an obnoxiously long amount of time to stand and wait, right? Maybe an hour or 2 hours, or I set this to 99999, so it's basically to stand there infinitely until they're told to move. Then we have an attribute modification. And so what's going to happen is when the vehicle arrives, this attribute modification is going to trigger certain pedestrians, and it's going to modify the dwell time attribute. So when it's time for pre-boarding or when it's time for priority boarding, right, it's going to find those pedestrians with that certain boarding status that we assigned before, and it's going to say, okay, only you with this specific boarding status, your dwell time is now 0. So that means you can go line up at the final check, the gate entry, which is a queuing area. So they all line up in a straight line and proceed through to the public transit waiting area. But since the vehicle's already there, they just immediately board. All right. So in this case, we're going to create a user-defined attribute called boarding status and a free distribution. We've seen this a few times now, and we assign that to the pedestrians using a pedestrian attribute decision. The other thing we have is on the pedestrian area, again, in the gate, we have a time distribution. In this case, you can see the time distribution is set to 10,000 seconds. So pedestrians are just going to sit there and wait for 10,000 seconds. but really there's going to be an attribute modification that we're going to use that will adjust that. Then on the vehicle, we create a user-defined attribute called current boarding group. So the vehicle is going to be dwelling for X amount of time. And in this case, we've created different states. So in transit, deplaning, resetting, priority boarding, general boarding, and doors closed. So as that dwell time ticks down, if the dwell time is greater than 4 minutes, right? Obviously, I've sped this up a little bit, so it's not realistic to an actual plane procedure. But if it's longer than 4 minutes, then they're in transit, meaning that the plane is still taxiing up to the, then they're set to status 1, so they're deplaning. And then if it's greater than 3 minutes, then they're resetting. So people have deplaned, but people can't board yet. And then if the dwell time is greater than 2 minutes, then we go into priority boarding. And then if the dwell time is greater than 1 minute, we go into general boarding. And then if it's less than 1 minute, the doors have closed. So that prevents people from proceeding on. I also like to create an area attribute. You don't have to do this step, but basically it says it pulls this data onto the area itself. It just makes it a little easier for the pedestrians to look up. So you don't have to do this lookup table for each pedestrian. You just do this lookup table once for the area, and it will, then the pedestrians can access the area directly. So this attribute is just saying, give me the status number of the bus. Then, once we have the status number of the bus, we feed that into another attribute called now boarding. And the reason I created this attribute was because I wanted this sign to update, right? So now boarding, priority, general boarding, doors closed. And so in this case, I have a user-defined attribute that pulls that vehicle status. So again, what status are they in? And if they're in, the correct state, then it will read either status 1, 2, or 3, and then a user-defined attribute that then converts that 1, 2, and 3 into priority, general boarding, and doors closed as text value. So we can put that up on signage or put that into outputs. Once we have that now boarding state, so state 1, 2, 3, priority, general boarding, or doors closed, we can then take that user-defined attribute we created called boarding status and have an attribute modification that says, all right, if you are on area number 2 and your dwelling is greater than 900 seconds, so you haven't been modified yet, and your boarding status is set to 1, which in this case is priority, then once the plane goes into priority boarding mode, your dwell time is now 0. So the second that sign flips over from resetting to priority boarding or whatever, your dwell time immediately switches to 0, and all the pedestrians will go queue up. And then we have a second one for general boarding as well. So identical, but just boarding status is equal to 2 rather than 1. And so what we'll see is some people still standing by and waiting, other people boarding the plane. So let's go in and take a look at what that looks like. So here, if I switch my view over to boarding mode, as pedestrians, in this case, I have the boarding status assignment set up at the gate itself. So this pedestrian, for example, doesn't have a boarding status right now. Their boarding status is set to 0. But as they walk up to the gate, they turn green and they're assigned status 2. We have some people assigned status 1. And we can also see that the bus is currently in the deplaning mode. So if we look at their dwell time, it's at 182 seconds. So they're still in the resetting mode, this yellow mode. If I advance the simulation a little bit, here we're at 180.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1. The second it turns over to 180, they go into priority boarding mode. Then this area that all these people are standing on is reading that status. And when it reads, okay, they are in state 4 or whatever this priority boarding mode is, change my attribute to now boarding is set to priority. And so we can see that the signage changes. And we can also click on this person, their boarding status is 1. If we look at their current dwell time, their current dwell time is still set to something like 9 10,000 seconds. But after a couple seconds, it resets and their dwell time zeroes out. So now we can see the purple person is going up, and then they do their final ticket scan, and then they go and board the bus or the plane. When this bus eventually gets down to 120 seconds, so I'm going to hit play for a little bit. Let it run. Got about 15 seconds left. Here, let me actually turn on, can I show my simulation time? Yeah, there we go. Okay, so we can see the simulation time here. I guess we want to show the dwell time. Dwell time right now in about 1 second is going to switch over to general boarding. And we can see the bus changes, the board changes to general boarding, and all of our green people go and line up to get into the queue for the boarding procedure. And then once the bus has waited and everyone's boarded, the status will eventually change to doors closing. And so now we can set the status to doors closed. Now, none of these are hard-coded to the simulation time. These are all based on the vehicle. So if your plane arrives late, all of these things will be offset a little bit. If your plane arrives early, they'll be offset a little bit as well. So the doors are closed. Any new people will have to wait for the next plane. Okay. Sorry, I know I'm going fast through this, but there's a lot to cover. Next is the arrivals gate. So after everyone's boarded the plane moves to the next side, right? Typically, you're not going to do two separate airports in one model, but this would be some planes arrive, some planes depart, right? So we looked at the boarding procedures. Let's look at the alighting procedures. So when a plane arrives at a gate, when they're still in that deplaning mode, pedestrians are going to get off of the plane, and we're going to have a static route that sends them to the concourse. And so that static route is going to say, okay, there's a certain number of people that are connecting or they are exiting, right? So connecting passengers or not, right? So we send them to that concourse, and then we use an attribute modification to change pedestrians from arriving to connecting passengers. So in this particular model, I have different pedestrians set up for departing passengers and arriving passengers. The reason for that is because in a real model, you're going to have both these arriving and departing procedures on the same facilities. And so you're going to want the static routes for all the departing people to be going in one direction and all the static routes for the people arriving to be going in the other direction. So you want them as different pedestrian types so you can give them different pedestrian classes. So when a person gets off of the plane, they're going to come off as an arriving passenger. But some of them may not necessarily go all the way through to baggage claim. They might go to other gates. And so in that case, a connecting passenger, those people would get switched over from one pedestrian type to the other, so they become connecting passengers. And then we use an attribute modification to assign them a gate. So if you are an arriving passenger, you just continue on to the arrivals. If you're connecting, you go here, where you are then assigned a gate, and then you go, and then you go here to figure out, okay, where am I going? Sorry, I wanted to go to the next slide. There we go. So here we have an attribute decision that says, okay, if you're a connecting passenger, we need you to change your ped type. So over here, we see all the pedestrian types that I've created. And this looks like a lot, but you kind of add these in as you build things along, right? So we have our departing passengers, departing men, women, and wheelchair users. We also have arriving, and then we have connecting. So in this case, if we've numbered these sequentially, so departing is always ends in a 10, connecting always in a 20, arriving always in a 30, and baggage claim is always in 40, then all we have to do is just subtract 10 from what, if we're changing it from arriving to connecting, we just subtract 10, and that will shift anyone over regardless of where they started. Next, for the departure gate, we have that user-friendly attribute we saw before. And then we have a free distribution that says, okay, here's the connecting gate assignments, right? And so we can assign them to various connecting gates using an attribute decision, and then a partial route to assign them to their next location. So for example, we come over here, Gonna let it run for a hot minute. Hopefully this bus gets moving here in about 30 seconds. So the bus, AKA the airplane, is coming over to the next gate. It stops, pedestrians alight. So now we're looking at deplaning. So in this case, we can see, based on the colors, the red ones are arriving women, green ones are arriving men. So the connecting passengers are moving on to this square and they're getting changed to being connecting men. And she gets changed to a connecting woman. And then they go to their next departure gate board. So this is, they look at the departures board, they see where their gate is. So they'll stand there for a second and then they'll move on. What's happening is we have our static route that says, go to this area, and if you a certain percentage will be navigated onto this this pad, and on this pad we have them changing their ped type. And then once they've changed their ped type, they continue on to see where their gates are. So I call this gate assignment, or it's like a departures board. So they go there and they look at where their departures are, and then after that, they go back to the concourse. And on the concourse, we have a formula-based route, just like on the other side. It says, all right, if your gates have certain numbers, go to those different locations. Otherwise, go to baggage claim. And so that's what happens. So if they aren't assigned an alternative gate, they'll go to baggage claim. And that'll be the next thing that we look at is baggage claim. Before we get into baggage claim, I want to ask the final poll question. Would you like further information on adding more pedestrians or Viswalk to your Vissim license? So a lot of the things we're looking at right now are specific to Viswalk. And so I wanted to see what you guys' opinions on this one. All right, thank you for responding to our polls. We're still gonna have Q&A at the end, but we're gonna go through baggage claim and arrivals real quick, and then we'll get on to that. Okay, so baggage claim. Once the pedestrians have decided not to connect to another gate, they move on to baggage claim. This one gets a little complicated because there's a lot of moving parts. For visualization purposes, I wanted to have bags actually trolling around on the carousels. So in this case, what we have is we have an attribute decision at the beginning of baggage claim, just like always, that says which baggage claim carousel do you need to go to, or do you skip it, right? So you might have three statuses, none, carousel 1, carousel 2. So they get assigned a baggage claim carousel at the beginning. Then we have a static route that is navigating them based on that baggage claim carousel assignment. And then, and you can see that it has a few stops. So they walk out to baggage claim, and typically this is where the boards are gonna be, right? It's gonna say, okay, your flight goes to one or the other. And so they're gonna walk past the first couple of carousels and then go to these boards and then turn around. And once they are assigned to the correct carousel, they'll turn around and then they'll just wait in this area around. So we have this horseshoe shaped area around the baggage carousel, and that's just kind of a waiting area. And just like we did with the boarding gate, they're set to 99999 until the bags arrive. So they're just standing there waiting for an infinite amount of time until their bags arrive. Then we have an attribute modification. So when bags do show up on this, because I don't have it running all the time, I have the vehicle input of the bags set so that the bags show up at specific intervals of time. When the bags actually show up, we have an attribute modification that then starts to change the dwell time of the passengers. So from there, it's going to go and change the dwell times from 99999 to some random distribution based on how long it takes you to pick up your bag. From there, we have a formula-based route that says, okay, if there are passengers waiting at this area, because sometimes the bags arrive before the passengers. So if the bags arrive before the passengers and there's nobody waiting at the area, the bags just kind of repeat this loop and they just keep looping around until passengers arrive. And then once those passengers arrive, we have a formula-based route that says, okay, if there are pedestrians on this horseshoe, start navigating some of these bags off of the carousel. So we have a little exit on the carousel so the bags disappear. And finally, we have an attribute decision so that after the pedestrian has made their way to the baggage carousel, they've dwelled, the bags show up, so their dwell time gets changed. After they've dwelled and they move on, you see that they step forward onto another blue horseshoe that's just inside. So that's like the pedestrian walking up and grabbing their bag. We have a final little pedestrian attribute decision. You see this gray dot here. What this does is this changes the pedestrian type from pedestrian arrival to pedestrian baggage claim. And the reason I did that was because we want to have pedestrians without bags, and then they change into pedestrians with bags. So we're changing what they look like, and so we're changing the pedestrian type. So again, walking through it, we have our user-friendly attribute called baggage claim. So this tells them what carousel to go to. And then we have a free distribution that randomly assigns people to their various carousels. Then, based on that baggage claim attribute, we have our formula-based route that navigates them to either skip baggage, go to carousel 1, go to carousel 2. And then when they get to that pedestrian area for their baggage claim, they wait for 9,999 seconds. Then, if the bag arrives, we update the PED dwell time. So the dwell time is set to 99999. So if they're at the correct baggage claim, then their free distribution gets changed to something like average of 40 seconds or something like that, right? So you'd create a distribution based on how long it takes them to pick up the bags. And then if the PED arrives, so if the bags are there first, if the PED arrives, here's the vehicular formula-based route. They claim a bag or they don't claim it, or we recirculate the bag. Sorry, that was really hard to say, really fast. All right, so let's take a look at those operations. So we have pedestrians arriving at baggage claim. So we have one carousel with bags already circulating. And then we have another carousel where bags have not arrived yet. So in this case, some passengers are getting passed off to various, if I look at baggage claim. So the red baggage claim, i.e. our Delta passengers are on this side, our United passengers are on this side, and then green means that they're just skipping baggage claim altogether. So on the blue side, you see them just standing and waiting because no bags have arrived. So they're just gonna keep piling up over here. Whereas on the red side, they come and they stand, but their dwell times for the pedestrians are not set to thousands of seconds. So here, the blue person is set to like 10,000 seconds. The red person is set to some random value between 0 and 40 seconds. After that dwell time has expired, so here in about 3 seconds to 1, we'll see this pedestrian switch from a person without a bag to they'll walk forward and they'll grab their bag and they'll walk away. So again, we're looking at a passenger here, this man, dwell time is 0, so they step forward, they grab a bag, and then they walk away. And then they proceed on to the next location. Okay. Finally, after you've arrived at the departures curb, you've gone through ticketing, you've gone through security, you've boarded your plane, you've got off the plane, you've found baggage claim, you've gone through, grabbed your bags. Now, finally, you need to get picked up. So the arrival's curbside, we're gonna look at that. So in this case, I thought I saw some questions about double parking. We do have double parking, so we can show that. It's basically just 2 stacked parking lots in adjacent lanes. I would advise making the double parking lane stalls a little bit longer than the inner lane so people can kind of navigate out. But here we have, as the pedestrian walks onto the arrivals curb, we have a pedestrian attribute decision that assigns them a mode of transportation, right? So you walk out, you follow the signs to ground transportation, you know, am I taking a cab? Am I taking a ride share? Am I getting picked up by somebody? Am I taking a shuttle? So as they walk out the door, we assign them a mode of transportation. We then use a formula-based route to navigate them to whichever curb is appropriate for them. And we have an attribute modification. In this case, the attribute modification adjusts the vehicular demand. So we have our parking lots and our vehicular demand generators. So we have cars that are navigated to the arrivals curb. But instead of just having a generic value for like X number of cars per hour, we're going to use an attribute modification that says if a person is waiting here, send some cars, right? So in that case, we can have the demand be dependent on the arrivals of the passengers. So that looks like we have our ground transportation user-defined attribute. We have our free distribution, randomly assigning which ground transportation mode they're taking. We then have our static route that has a formula that says, all right, if you're going to the private curb or if you're going to the taxi curb. And then once they get to the arrivals curb, they're going to just stand there for X number of seconds. We could make it a little bit more complicated where they wait for an entire car to show up, or you can make it so they just stand there for an arbitrary amount of time. For private transportation, I go for the arbitrary amount of time. And then we use a formula-based route that just basically says the vehicle input for the private transportation is equal to the total number of waiting peds minus the total number of currently waiting cars. So it looks at, you know, you have 100 pedestrians at the curb and you have 20 cars at the curb. If we're assuming one person per car, right, then effectively there needs to be 80 more cars sent to the curbside. If you want to have multiple people per car, then you just add a little multiplier in front of it. And then I have a car coming every 90 seconds, right? So if we need another 60 cars to show up, they're going to come at a flow, or sorry, not every 90 seconds, but this adjusts for the flow rate. So if you need, you know, faster cars, you make that value higher. And then if it's 0, if no pets are waiting. So it's pretty straightforward. This chart looks complicated because what it's doing is it's doing some lookup tables. So it's pulling data from the area and from the counted parking lots. And then if you want to do it another way, taxi stand rideshare, similar thing. You have your demand generators, you have a parking lot, and you send taxis to there. The only thing we're going to do is we're going to have two attribute modifications. One that says hold the pedestrian until a car shows up, and then another one that says hold the car until the pedestrian shows up, similar to baggage claim. So we have a pedestrian waiting for an infinite amount of time, and then we have a attribute modification that says if there's room for more taxis, send more taxis. And then once the taxis are there, we say, okay, if there's a pedestrian there, the dwell time of the taxi goes from infinite down to whatever the boarding time is for a person into a taxi. And then vice versa, if a pedestrian is there and a taxi is there, change their dwell time to whatever a pedestrian boarding time would be for that taxi. So before I move on to Q&A, just showing that really quick, here we have, I'll go into 2D, we have the departures or the arrivals curve. We have our attribute modification that says arrivals demand. And so here's just the formula for that. And it's updating this vehicle input over time. So as more people show up, that input value gets bigger and bigger, so that it sends more cars down. On the taxi stand side, we have a pedestrian that walks up. So right now this taxi is waiting for an infinite amount of time. And the taxi queue is so long that this vehicle input is set to 0. So as that pedestrian walks all the way around the taxi stand, they're going to get there eventually, I promise. Walk up, walk up, walk up, walk up. Get to the front of the taxi stand, talk to the agent there. As this pedestrian steps onto this area, the dwell time for this taxi is going to get updated. So eventually this dwell time for the taxi should get updated and the pedestrian will board. I think I just have a thing going. So the pedestrian boards and now the taxi can take off. So that's really what we got going from there. So this is the whole kind of view of it. So again, we have our demand that's kind of arbitrary based on traffic counts and things like that, that's generating pedestrian demand. Coming into the airport, then they board, alight, pick up their bags, and then over here on this side, we have the pedestrian demand that is driving the vehicular. All right, so I know we're a little behind, but I wanted to open up for Q&A for the last little bit. So I guess, Sean, do we have any questions that you wanted to point out? I saw you're getting to most of them in the chat, but are there any ones that you wanted me to go through?
Yeah, can you hear me?
Yeah, I can hear you okay.
Yeah, I'm getting a little pedantic in the comments here. I did get a lot of thank you, Levi, and this is a brilliant example that should be included as part of the distribution, which I agree with. But that being said, generally speaking, I've written it about 15 times already, but if you haven't read the examples, we do have ptv.to/learn, where we have all of our previous talks, and we generally put our model examples in there and files to experiment around with. And this one is a perfect one for that purpose. Let's see what else we have. You answered about the double parking. There was a question about double and triple parking. There was one question that asked if we could assign attributes on the fly using a set of conditions. I had mentioned attribute selections that you can turn things on and off. I didn't know if you wanted to expand on that question. I answered that in several different questions in several different ways.
So there are two different, sorry, I'm trying to get out of this and go into, where is my Vissim model? There we go. There are two different ways to dynamically assign attributes. One is based on a specific geolocation, right? So if we look at the arrivals curve, right, we have a specific object called the pedestrian attribute decision. And this will change the attribute as a pedestrian walks into the space. We also have vehicle attribute decisions that do the same thing. So as the vehicle drives over that bar, their attribute gets updated. If you wanted a continuous update, anywhere in the model for your vehicles, then you would use, in the actions, you go to the attribute modifications. So this is where you would come in and create something that would say, okay, pick an attribute that you want to update. And then over time, so for example, this one is the arrivals demand. So based on the formula that we specified down below, we have vehicle input number 2 constantly updating in real time based on whatever this formula is. So those are really the two ways that you can go about it, either globally using an attribute modification, or at specific locations using either a vehicle attribute decision or a pedestrian attribute decision. Here you have the same options. You can still do a formula-based route, and you can still pick your attributes. It's just it only comes into play when the vehicle or the pedestrian steps onto that space. Whereas the attribute modification works globally. So you kind of have to be careful about those global settings so that it only affects certain vehicles or certain pedestrians when you want them to. Oh, does that answer the question, or did I kind of miss the point?
Yeah, I mean, you answered. Okay. Yeah, I answered a very specific thing, and you expanded on that quite well. And as I've mentioned in the comments, Levi did at least one very good attributes talk that goes into detail on that. I started to answer this question about pedestrians with bags, bigger and smaller. It does, the size, as far as I understand, does affect a bit with the social force dynamics. They did ask about group dynamics, which I know is one limitation with some with Viswalk. Maybe you want to talk about how the pedestrian is and how it affects them in the simulation, I guess is the question where.
Yeah, so to answer the first part, the bag does affect the size of the pedestrian. So if I click on a pedestrian without a bag, you can see the little yellow collision box around that pedestrian. So that kind of defines the personal space of this pedestrian. And if you see a similar pedestrian with a bag, it's just wider, right? So in this case, they're pulling the bag beside them. But if you had a model where they're pulling the bag behind them, or maybe they had like a trolley or something like that, so the size of the pedestrian or the size of the vehicle does affect it. In Viswalk, the social force model, I believe it works to the edge of the collision box, not to the centroid of the pedestrian. Like every time we describe it, we're always talking about like points and vectors, but those vectors, I believe, are acting off of the collision box, not off of the centroid of the pedestrian. So bigger pedestrians will take up more space. So in that sense, if you're looking at something like density, right, you'd expect the density of baggage claim to be lower than the density of a terminal where maybe they don't have bags, because there's just the people take up more space, right? So but as far as like the calibration goes, it's going to be very similar in terms of that. So you don't really have to worry about the size of the pedestrian. Now, oh, go ahead.
Go ahead.
Oh, I was just going to say, so that's one of the reasons why I chose to have them switch from one state to the other. So that way the size of the pedestrian is automatically accounted for in things like social force models and walking through crowds and things like that, right? So
What I was going to say in addition with calibration and model building is if you look in 2D, the different pedestrians are represented with different circles, and that will also affect how they enter very tight areas. So if you have queuing ropes or very tight curves, wider pedestrians might get stuck or have trouble in the calibration process.
yeah. And then as far as groups go, we don't currently have grouping of different agents into a group. You can create like a pedestrian model that is a pedestrian group, like it has like 5 pedestrian models, but they all would walk around together in a static formation. So like if you had like people marching through in like a line, right, that'd be one thing. But it doesn't really have those flexible group dynamic models yet. We're currently rebuilding the underlying infrastructure of Viswalk so that we can do more stuff like that, but we're still working on that.
And for users of Viswalk, when we say we're rebuilding it, you don't have to relearn everything from scratch. It's more on the back end, make it more features. I'm getting hundreds and hundreds of messages again about the recording. I believe that people who are registered will get an email with a link to the recording, but again, ptv.to/learn. We keep our PTV Talks, their model files, all of that kind of stuff. So please visit. You don't have to be a customer, but we prefer that you are a customer and be a part of our family, but this is all free to use for anyone, so check it out. Before we leave, I got a really interesting question for you. The attribute selection for letting the pedestrians out in the taxi queue, how do you make that more than one person in a controlled way? Is it possible?
Yeah, so basically the logic I have is I have the taxi stand for pedestrians, releasing pedestrians, and then taxi stand for the car. So here what I have is I just have a queuing area with a dwell time on it. And so when I release, and I have a what's it called, a service point selection route that just says, all right, if there's nobody standing on this orange spot, then proceed forward. So I could just change this to like a 1 or a 2 to have a group of people kind of walk up all together. And then this automatically just looks at everybody on area number 68 and changes their dwell time. Currently, there's only one person at a time on Area 68. And so the easiest way to do it would just be to come into here and just take this route right here and change this to like a 2 or 3. And then in that case, 2 or 3 people could queue up if they needed to. So the way I've set up the attribute modifications currently, it's genericized so that hopefully you can send more people or fewer people, and it should work.
Awesome. Well,
the last thing I will say, Sean, before we close out, is we do have a training coming up, or we do have trainings for user-defined attributes and attribute modifications. So in addition to the free PTV Talks, which is like another hour-long webinar on tooltips, you can go find those in PTV group or ptv.to/learn. You can also go check out when we're having trainings, and our next one is in June if you wanted to attend a training, which would be 4 hours on just talking about user-defined attributes and attribute modifications if you wanted more details on it. I'll post that in the chat as well so people can copy it real quick.
Awesome. Well, we'll hang on here for a minute. That's the time. We don't want to hold on to people too long, but we'll continue to answer the questions in the chat here for a minute. And if you have any more questions related to sales, licensing, that kind of stuff, info.us@ptvgroup.com. Levi, what's your support email again?
It's support.us
@ptvgroup.com. And thank you, Levi. Thank you very much for the nice presentation.
Yeah. All right, we're seeing people starting to log off, so I'm going to close out on the presentation. Thanks, everybody.
Thank you, everyone.